welcome to EasyElimu Learning Simplified. My name is Ruth, and today we are going to be looking at nitrogen and its compounds, and specifically, we're going to be focusing our attention on some of the properties of ammonia gas. So these properties will be majorly chemical properties, although we are going to mention a few physical properties that align to what we discussed in our previous lesson. So first of all, ammonia has a characteristic pungent smell, and it's very soluble in water, as we saw in the fountain experiment in the previous video. So when ammonia dissolves in water, it dissociates to form ammonium ions and hydroxyl ions, and the hydroxyl ions are the one that gives it its basicity, or it makes it to be basic in nature. So formation of hydroxyl ions means that the aqueous solution of ammonia is weakly alkaline, and so it will turn the universal indicator purple. So the first reaction we are going to look at is the reaction of ammonia with acids. So sulfuric acid and concentrated ammonia solution are put in a dish and heated slowly. The mixture is evaporated to dryness. So what you notice is a white solid will be formed. So ammonium hydroxide, remember we have said it's ammonia solution, not just ammonia gas, it's ammonium solution. And previously we have said ammonium solution is formed when ammonia reacts with water to form ammonium hydroxide. So the ammonium hydroxide reacts with sulfuric acid to form ammonium sulfate and water. This is different from when ammonia gas reacts with sulfuric acid to form ammonium sulfate only. So ammonium sulfate is formed in water. So this is the ionic equation. Looks like an equation for a neutralization equation which has the same ionic equation as shown. So to some of the resultant white solid, we added a little bit of sodium hydroxide and the mixture was warm. The gas evolved was tested for ammonia. So the ammonium sulfate reacts with sodium hydroxide and then it forms ammonia. So ammonia and also water. So you see there is an interchange of ions that happens. So there is ammonium sulfate reacting with sodium hydroxide to form sodium sulfate. So the sodium took the sulfate ions from ammonium sulfate and then it formed sodium sulfate, and then the ammonium sulfate you see is a dissociation that happens to form ammonia gas and water. The evolution of ammonia shows that the white solid formed is an ammonium salt. So the ammonia reacts with acid to form ammonium salt and water only. So also ammonium hydroxide can react with other acids like hydrochloric acid and nitric acid. So when ammonium hydroxide reacts with hydrochloric acid, it forms ammonium chloride plus water. When ammonium hydroxide reacts with nitric acid, it forms ammonium nitrate and water. So you can see it's the same, it forms a salt and water in whatever acid it's going to react with. So the next is the reaction of ammonia with oxygen. So both dry ammonia and dry oxygen are usually dried. They have to be dry before you carry out the reaction. Otherwise, you know ammonia is soluble in water. So ammonia extinguishes a lighted tapper because it does not support burning. It's non-combustible. However, it burns in air enriched with oxygen with a green-yellow flame. So we say that this air needs to be dried. So when they're ignited, colorless gas is liberated. Some droplets of colorless liquid are also collected at the cooler parts. Some of the conditions for this reaction to occur is they need to be dry. That's it. That must be there. It needs to be dry ammonia and dry oxygen. And then air must be driven out of the tube, because if it's not driven out of the tube, it's going to interfere with the reaction. So ammonia burns continuously in oxygen, forming nitrogen and water vapor. The ammonia is oxidized as hydrogen is removed from it, leaving nitrogen. So the glass wool slows down the escape of oxygen in the combustion tube, thus providing more time for combustion. So you see the glass wool where it has been placed, and you can see where the oxygen is coming in. So you see the oxygen has directly been placed on the glass wool. So this allows the escape of oxygen to occur slowly. So it will give it more time to react with the ammonia gas. So that's the equation. Ammonia plus oxygen forms nitrogen gas and water. Ammonia also reacts with air enriched with oxygen in presence of a catalyst. And our catalyst in this case is a platinum wire. So you see now our dry oxygen, you see it's still dry, is comes in with like this tube, and then we have some concentrated ammonia solution. So ammonia actually is volatile, so it forms ammonia gas in the process. It's very volatile, and then when the hot wire is heated, so on top of it, it provides a surface for reaction. So the dry oxygen reacts with ammonia, but in this case, instead of forming the oxide of nitrogen that is formed in the previous, it's going to form nitrogen 4 oxide. So concentrated ammonia solution is put in a conical flask. The platinum wire is heated until it's white hot. Oxygen gas or air is then passed through the ammonia solution. So the red hot platinum wire is then put into the flask containing the concentrated ammonia. So the hot platinum wire, these are some of the things you see. It glows and then some red brown fumes are produced. So the hot coil glows when it comes to in contact with ammonia, which comes from the ammonia solution. So the reaction between ammonia gas and oxygen takes place on the surface of the platinum catalyst. It speeds up the reaction. So a lot of heat is produced in the reaction that enables the coil to continue glowing. Ammonia is oxidized to nitrogen 4 oxide, which are the red fumes that you observe after some time. So ammonia plus oxygen to form nitrogen 2 oxide, which quickly forms nitrogen 4 oxide. We said one of the thing with nitrogen 2 oxide, when it is exposed into the air, it oxidizes very quickly to form nitrogen 4 oxide. Next, ammonia also reduces some oxides of metals below iron, the reactivity series. Remember, we mentioned this when we were preparing nitrogen. So ammonia is passed through a tube containing copper 2 oxide. It's going to reduce copper 2 oxide to copper metal, and itself is oxidized to nitrogen and water. So copper 2 oxide is heated strongly and dry ammonia is passed over it. The products are then passed through a U-tube immersed in cold water, as you can see. So copper 2 oxide will glow as the reaction is very exothermic, and then a colorless liquid collects on the U-tube. The colorless gas is collected over water. So when you look at the color change on the copper 2 oxide, it changes from black to brown. So it changes from copper 2 oxide to copper metal. This is because ammonia gas reduces copper 2 oxide to copper and itself is oxidized to nitrogen and water. So this reaction forms water, copper, and nitrogen gas. And then a reaction with chlorine, ammonia is passed into a bell jar containing chlorine. So it catches fire and burns while at the end of the tube, and the flame goes out and the jar gets filled with dense white fumes of ammonium chloride. This is quite similar to when ammonium chloride was reacting with when ammonia gas was reacting with hydrochloric uh, gas. So they form the same product. So ammonia plus chlorine will form hydrochloric acid plus nitrogen. Then hydrochloric acid reacts with ammonia to form ammonium chloride. So basically the overall reaction, we are forming ammonium chloride and nitrogen gas, which is totally different from when ammonia reacts with hydrochloric acid or hydrochloric fumes. So you see this, in that case, it's only one product that was formed, but in this case, you're forming two products, that is ammonium chloride and nitrogen gas. So if you look at this one question in regards to some of the properties of ammonia. So identify the brown fumes observed. So the brown fumes are nitrogen 4 oxide. Write the equation representing the catalytic oxidation of ammonia. So we said it's ammonia gas that reacts with oxygen to form nitrogen 2, which is oxidized, plus water. So let's see if it's balanced, so that we can balance it. So it becomes 4. So here it becomes 4. That affects the number of oxygen. So you put a 5 here. And that's 6 here. So that we can have 6 plus 4 oxygen, 10. And then 5 times 2, 10. Formation of the brown fumes. So it's nitrogen 2 oxide plus oxygen gas to form nitrogen 4 oxide. So we put a 2 here, it's going to be a 2. So that's balanced. So we have 2 plus 2 oxygen 4. So this is correct. So that brings us to the end of this session. See you in the next lesson as we look at now the large scale preparation of ammonia.